Okay, well, we are about to move on to the last of our plenary presentations. And Doug Muzyka, who's the Senior Vice President and Chief Science and Technology Officer from DuPont, will be presenting that. Doug has served on a number of advisory boards for universities, industry associations, and business councils on sustainable development in Canada, Mexico, and China. He earned his bachelor's, master's, and postdoctoral degrees in chemical engineering. So hopefully he got to hear lots of chemical engineering and enjoyed that. And we're very much looking forward to his presentation on reducing our dependence on fossil fuels, an industrial perspective on energy research.
Thank you, Sally. It's a real pleasure to be able to have an opportunity to speak to such a diverse group. As we learned at lunchtime today, we've got all of the role models of innovation present in this room, so it's really a pleasure to have this opportunity. Speaking to this topic is a pleasure for a couple of reasons. Last night I was at the Founders Dinner. DuPont is actually a new participant in GCEP, and it was interesting not only to meet the people that were here at the inception, but to get a bit of a perspective of how the first 10 years went. And Lenore made a comment kind of summarizing what was most gratifying for him in the course of the history of GCEP, and that was what we were working on here is really important. And I think that's a real truism in the energy space in general. What we're working on here is not only important for every one of us in this room, but everyone beyond us in this room. And it goes much more beyond the price of gasoline in California this week. It goes to things that are truly going to affect the future of all of us here and the future of our children. So it's an important topic to talk about. Secondly, as a chemical engineer, I think the science that underlies what we're doing in energy research is really fascinating. What was always gratifying for me as a chemical engineer is to start with good science and then be able to see that science make its way to the marketplace in a way that was really having a commercial and important impact. And if you look at this space, what you do see is long-term research working in areas of foundational sciences that are really very powerful. But you also see innovation flowing to the marketplace at a tremendously rapid speed. And some of the examples I'm going to share with you, from our perspective at least, I think illustrate that really well. So as my title indicates, I'm going to talk about a perspective from a large industrial company, but a company that's not an energy company per se. We're not in the oil and gas business. We don't generate electricity, but we see the energy space as a really important one, and where we can, through the science that we have in DuPont, make a contribution to moving the ball forward in this regard. I have two messages that correspond to the talk today. One is, on one hand, you can feel really intimidated by some of the challenges facing us to have these systems come together and be able to reduce our dependence on fossil fuels. It can be intimidating, and they can all be seen in a negative light as things that we actually have to overcome. But what I like to illustrate is, and this is true in our company, as we invest in the future, we see these challenges as opportunities to grow, opportunities to create value, and frankly, opportunities to capture value. And so the bottom line is we see this as good business going forward in this energy space. The second thing, and I'll kind of illustrate that progressively through the course of my presentation, is we have come to the conclusion that science is the key to being able to solve these problems, and more science in a collaborative sense of the kind that we're trying to create here in GCEP is fundamentally important in order to be able to do this. And so I'm going to brag about the capability we have in our company a little bit in the first part of my presentation, but what you'll see as I get progressively into it, it becomes more and more complex, and frankly, the problems that we're addressing here go well beyond the capability of any individual company, any individual entity to be able to solve in isolation. Collaboration is the key to what we need to do to be successful. So for those of you that aren't familiar with DuPont, let me tell you a little bit about our company. We've had a 210-year heritage of working on science and technology and trying to bring better solutions to the world as a result of that. We started as an explosives company. Through the course of the full 19th century, we did nothing but explosive, black powder, and that was what the company did for that period of time. And then we diversified in the 20th century, and we diversified recognizing that in the industrial domain, basic research, basic scientific research could be the key to us being able to make progress going forward. And so we were a very active participant in the revolutions in the chemical industry that occurred in the early 20th century, to the creation of the synthetic fibers industry, for example, and the textile industry that flowed from that. And where we, through the course of our history, had an opportunity to be successful, it wasn't because we were the world's best marketing company, but we try to do that with our brands, and it wasn't because we were the most cost-effective manufacturing company, but we work hard on that too. Where we've been successful in our company is where we've had a competitive advantage that flows from a scientific differentiation base, and that's why we continue to aspire to be a dynamic science company, and this is what guides us as we move into the third century of existence in our company overall. And secondly, because we were in the explosives business for the first century of our existence, we developed a really strong ethic around safety and the environment. In fact, there are stories of the founder of our company building his house within the blast zone of the factories that first made the black powder that the company started to commercialize, as a demonstration of his own personal commitment to not only having a safe environment for himself and his family, but those are the workers that had to work in that environment on a daily basis. And so it was a natural for this to grow out of that focus that we had on safety and the environment in the early part of the company, to embrace the broader concept of sustainability when it became developed further on in all of its component parts of trying to create societal, environmental, and economic value simultaneously. And you should be able to see this as a thread through almost all of what we do in science and technology in DuPont. Companies that survive for 200 years have to shift their portfolio from time to time. We wouldn't be very successful today if we were still in the explosives business. And so we have shifted our portfolio in significant ways, really in two phases, as we diversified through chemistry in the 20th century and as we added biology to the foundational sciences that we have in the company in the 21st century. And so this is kind of what DuPont looks like today in terms of where we focus our effort in science domains. On the right-hand side, advanced material sciences, this is where you'd normally find those things at a consumer level that you might associate with DuPont. So this is where Kevlar and Tyvek and Teflon and Corian exist. It's still the major part of our company. It's more than half of our revenue in total in the material science domain. And we still believe it's got a tremendous opportunity to have innovation bring increasing value in the spaces that we operate in material sciences. In the last 20 years, we invested in a very important way in production, agriculture, and nutrition. We purchased one of the leading seed companies in the world, Pioneer, and we have a very strong position both in seed, agricultural chemicals, and working increasingly downstream in the nutrition area as another foundational area for the company. And then in the last decade or so, we incubated, for what was for us at least, a new space of industrial biosciences, where in fact we are trying to adapt biological processes to make the kinds of materials that are industrially relevant and which we have a strong market position as a result of our legacy in that area. And in fact, in the last year, we made a significant contribution to strengthening both the nutrition side of our business and the industrial bioscience part of our business with our acquisition of the Danisco company, a Danish company that has, among other things, an important subsidiary here that's just located on the other side of campus called Genencor, which had a tremendously powerful industrial biosciences base that complemented that part that we incubated in DuPont over the last 10 years. And we believe we've got a leading position as a result of bringing these two entities together to really exploit the full opportunity of that space. And you'll see some of this in the examples that I give. It was interesting the other night, I met one of the GCEP students and they said, well, I know why you're interested in GCEP. It's because your companies are just short-term focused and you have to deliver results quarterly, and your shareholders will be upset if you don't. And so GCEP must be the vehicle by which you do long-term research. And I said, well, we are interested in GCEP for that reason, but the reality is if you look at where we actually invest our research, our research investment in the company, it's almost always associated with projects that are in the 5 to 10 to 20-year time horizon before we actually break even from a commercialization point of view, like you saw in the last presentation. And so what we try to do is we try to be responsive to the short-term fluctuations that are in our marketplaces and that our customers demand. But what we try to do in terms of orienting our investment is to hook it against those things that we think are going to be long-term persistent trends where we really have an opportunity to gain value from the major investments that we do here. And so for us, it's these three spaces that you see on this chart. Food, the quality and quantity of the world's food supply is going to continue to be under stress, and that's going to represent both challenges and opportunities. Keeping people and the environment safe is going to become increasingly important going forward into the future. And then this energy space in the middle where irrespective of whether oil is up or down this particular week, the fact of the matter is it's an exhaustible resource, and in fact there's going to be a greater and greater need for diversification of energy resources in order to be able to meet that challenge. So of the $2 billion that we invest in research and development in our company every year, fully 90% of that investment is directed toward things that are associated in one fashion or another with these three important megatrends. So what do we think that is necessary to be successful in this domain? And maybe it comes back to our legacy, but the fact is we see it reinforced day after day, and that's a really, really great science. And so to be a dynamic science company, what we've tried to do is to set ourselves up with a strategically managed set of scientific competencies where we aspire to be world class in order to be able to create the kinds of values that is inherent in the potential here. And you see this in this honeycomb picture. What you'll see if you look closely on the left-hand side, you'll see some of the competencies that we've nurtured in our company that have been around maybe a longer period of time. They're associated with our chemical engineering and our polymer science capability and our material science capability that was the legacy of our company through the course of the last 50 years or so. What you see on the right-hand side are some of the biology investments that we've made in competencies in the last 10 or 15 or 20 years, where you see highly relevant to things related to production, agriculture, and increasingly toward nutrition. And then in that center, you start to see emerging that little space of industrial biosciences that can draw on both things to be able to really create value in bioactives and enzymes and biomaterials and in biofuels. And so from the perspective of our company as a whole, we support these with foundational sciences, but the competitive advantage that we try to drive from this is to have these unique competencies come together, not only individually, but integrating in ways that really can create value. So we have formidable competitors in the material science space, and we have formidable competitors in the agricultural industry, and we even have competitors smaller in nature in general, but very adept competitors in industrial biosciences. But where we think we can bring additional value beyond the collection of those competitors is being able to take these sciences and have them work together to be able to create unique value in light of unique opportunities and unique challenges. And so I'd like to demonstrate that through a couple of examples for you quickly now. So I said at the beginning, we're not in the oil and gas business, but we're really interested in the opportunities that flow from the oil and gas business to be able to have safer and more productive operations. So if you look at our material science competencies in material science, polymer science, coating, nanotechnologies, we really believe that we can bring these together to be able to ensure and enable safer operations in the more difficult environments that oil and gas producers are facing to continue their production today. Examples of this are in this next chart. So our fluoropolymers, elastomers, and engineering resins really help keep piping and pipelines operating with high integrity in the oil and gas business. Our high temperature polymers allow substitution of metals in pumps, among many other pieces of equipment that allow these to have longer lives and in fact operate more efficiently in the environments. And then we have a whole array of our traditional chemicals businesses that enable oil producers through the course of their entire value chain to be able to be more efficient and more effective. Fuel efficiency is another example of where we try to bring our competencies together in a unique way to create value. In fact, fuel efficiency is in fact reducing dependence on fossil fuels. Why? Because you consume less of it as we become more and more efficient in our automobiles and our airplanes. So this is a real strong thrust for us, for example, in lightweighting of automobiles, to be able to replace metal parts with polymers that enable them to get more fuel efficiency overall. And so if you're looking at trying to make an air intake manifold out of polymers instead of metal, or if you're looking to make radiators out of polymer instead of metal, it really stresses competencies that you see kind of on the left-hand side of this particular chart. But you'll see the competencies that I've listed there are more extensive than the ones that I had up in the oil and gas example for a really good reason, and that's that we think that not only in the future are there going to be fewer metals and more polymers in automobiles, but we think that those polymers are going to be increasingly resourced from renewable materials, as opposed to drawing on fossil fuel feedstocks to be able to supply them. And so we are starting already to branch off from our original polymer domain into the renewables and the biological materials domain. And in fact, if you have a turbocharged hose in your car, it might be made of a polymer we call Hytrel, which is partially sourced from a monomer from renewable resources to make it more efficient and effective. If you look at these examples, so you confront, especially in the automobile industry, one real truism, and that's that people are interested in having renewables as part of the overall value proposition, but they're not willing to pay more for it in general. And so as we undertake the research on radiators or lightweighting of airplanes, or in fact aspiring to have entire systems made of polymers as opposed to out of metals, we have to really keep in mind through that whole process the value proposition, be it performance, cost, or a combination of those things, has to get better as a result of it. It's not simply aspiring to be as good as, it has to be better as, or it won't displace the incumbents in these spaces. Heard a fair bit about solar energy, and I was relieved. I was nervous in the last presentation as to whether or not this was really going to start to break even from the perspective of energy and cost consumption overall, and I'm pleased to see that it's at least headed in that direction, because DuPont's actually been involved in the solar energy business from its inception. In fact, 75% of all the solar modules that exist in the world today have DuPont materials in them. And we've developed materials almost for every aspect of solar cells, with the exception of crystalline silicon. And so we have our materials in the front side silver that conducts electricity away. We have them in the back sheets that are necessary to make sure that the solar cell is able to survive for 25 or 30 years on your roof. All the encapsulants that go around in making the whole package integral, and we work increasingly and try to integrate these together to drive, as everyone knows, toward the holy grail of grid parity without subsidies that we're moving progressively, in fact, progressively closer to every day. This is another science area that I think is really interesting, though. In fact, one of my favorite reviews, and I see in the front table, we've got some of our solar experts here in DuPont who are going to join the discussion later on in the afternoon. But there's fascinating science in all parts of this. My favorite is the conducting paste that goes on the front side of a solar cell to conduct electricity away. You could say that this is pretty low-tech stuff. All you really need is a silver conductor and then something to make sure that it adheres to the front of the solar cell. But the reality is, if you look at the fundamentals of chemistry associated with it and the impact that having subtle changes in that chemistry coupled with the way that is applied and then sintered onto a solar cell, and the potential it has to actually make 0.1, 0.2, 0.3% improvement in solar efficiencies to open more of the light spectrum to be able to be captured and be able to be turned into electricity. It becomes really fascinating science in a very, very tiny part of the overall system, but one that has a really big impact on the total performance in the end. Energy storage, we heard a lot about that here today, and frankly, from our vantage point, this is truly a critical intermediary in being able to allow many alternative energy technologies to really come together in an integrated system in a powerful way. And our view from our company, and this is one of the reasons why we're so interested in participating in GSEP with the broad activity that it has around energy storage, is this is not only an area that has huge potential for innovation to make performance improvements, but it's an area that the world needs the performance improvements almost more than almost any other space in the overall energy domain. And so in our company, we have materials that go into this today in important ways, and insulating materials and polymers and plastics that go into generators and batteries. But we're increasingly working on novel technologies like, for example, high temperature separators built on nanofiber technology, coupled with electrodes and electrolytes coming together in a system to be able to make real progress in this area. And so it's an important priority for our company, and it's an important reason why we want to work so closely with GSEP to advance this area as we go forward. A final short example I just share here is Sirona, and Sirona is not a energy technology per se, but the technology that underlies the innovations that we've brought to Sirona are really fundamental in enabling another priority that I'll talk about in a minute, and that is advanced biofuels. So Sirona is a polymer made from a renewable resource that is a 1,3-propanediol made entirely from renewable sugars in its origin through a metabolically engineered biological process. And why this is important is because this is not making products that are $1,000 a kilogram that go into the pharmaceutical industry through biological processes, and it's not making beer and wine, but it's a demonstration that in fact within the biosphere there's a capability to create what our GenEnCore colleagues call a cell factory, to be able to genetically modify a cell, to be able to direct the pathways toward consumption of raw materials and into products that are very specific in nature, high yield in nature, and are competitive with non-renewable resources drawn most often from fossil fuels. And so this is a process that we worked on in collaboration with GenEnCore through the course of the last decade or so, and has become a very important part of our overall materials portfolio, going into traditional end uses like carpets and textiles in very large quantities in a very, very special way. It's also interesting because it has a set of properties that are different than normal polymers. It's kind of got some aspects to it that it performs like nylon. It's got aspects to it that it performs like elastane or elastomeric fibers coming together in a thermoplastic polymer that goes into a fiber that sells not for hundreds of dollars a pound, but sells for dollars a pound and is very competitive in this market. So what this demonstrated to us was two important things. Number one, that this could be a viable way to be able to truly transform much of the chemical industry from having a chemical-only basis of transformation into having something that is much richer than that and has much more potential as we look forward to the future. What it also demonstrated, as we collaborated with GenEnCore through this whole period, is that it's impossible to do this thing by yourself. And so as impressive as we think our honeycomb of competencies are and how they can come together in really powerful ways, to be able to extend that honeycomb to the competencies that exist in partners and beyond is really a learning for us in this whole process that was really important and has changed our attitude toward open innovation in a very powerful way. So when we look then to what's needed to be successful in the challenges of diversifying our energy sources, it goes beyond just great science, and it's an ability to be able to create and operate great collaborations. And I'll illustrate this with a final example, and that's in the biofuels domain. So as you all know, and we've just been discussed here at this conference, ethanol has been around since antiquity. Ethanol production from grain in the United States and from sugarcane in Brazil is an important commodity and an important contributor to the overall energy scene in those geographies today. But the fact of the matter is, as we look forward to the future, the more sustainable way to be able to drive biofuels into the marketplace in important ways is going to be able to make them from cellulosic sources as opposed to grain and sugar sources. And this is what almost our entire investment in our company on biofuels is directed toward. It's the next generation of biofuels. So we have a commercial position in providing enzymes to the existing ethanol business. We have a commercial position in being able to develop corn hybrids that are amenable to having high yield from corn-based ethanol overall, but almost all the research that we do in the company is directed toward cellulosic ethanol and to a lesser extent butanol, which we believe has got an important role to play in the future as the next generation biofuel. But if you look at that, you can see there's a dizzying array of competencies that you have to draw on to be successful in this particular area. In fact, if you look deeper into a cellulosic ethanol process, as you can see on this chart, it's got lots of really complicated steps that you have to get right in order to be able to make this thing come together in a way that's ultimately viable from an economic perspective. You have a diverse and inhomogeneous feedstock it's spread out all over everywhere in the case of this particular example around corn stover. Being able to collect that and pre-treat it and get it into a state where the cellulose and lignin that form the materials are amenable to being able to be liberated and have the sugars be available for later fermentation is a really complicated enzymatic process that is very difficult to master and keep contamination out and be able to operate at a commercial scale. And then if you look at even the fermentation step, which you might say ought to be relatively straightforward, the fact of the matter is the sugars that come out of that process are different than the sugars that come out of the normal grain-based ethanol processes and require different microorganisms metabolically engineered again to be able to favor certain pathways to make all the sugars that flow out of that pre-treatment process to be available to be able to transform into ethanol. So there's a huge metabolic engineering process that needs to be undertaken to be able to fit into this thing and operate at really high performance standards. Again, this is a process that's challenged economically on almost every single aspect of it, from yields, from the capital investment necessary to support the size of the reactors that come together to have to do this. And so we're pleased to say that we think that the industry is ready to turn a corner around ethanol in general and start to move from grain-based sources over to cellulosic-based sources. We've been operating a pilot plant in Tennessee for the last 3 or 4 years at a full commercial integrated scale. As you can appreciate as engineers, you have to get all the recycle streams, all the water streams functioning together to be able to have the process actually be viable. And we're pleased to be in a position to announce our first full-scale commercial plant that's we've broken ground on in Nevada, in Iowa, and it's going to be started up on corn stover over the course of the next 12 to 18 months. But if we look back over that whole development experience, what you see is this truism about collaborations not only being important but being fundamental to enable the sciences that need to come together to have a process as complex as this really become viable. This is a tremendous illustration of that. And so through the course of this, we started with a DOE grant way back 10 years ago as a foundation in starting to work on the next generation of biofuels. We worked with universities on the feedstock feedstock preparation and some of the technologies associated with it. We worked on small companies that had a specialized capability in a particular area that contributed to this process. We leveraged the national labs that had, in fact, some of the bacteria developed in the early stages that had the potential to be metabolically engineered into something that would allow us to be able to make our process viable. And in fact, we even partnered with equipment manufacturers to be able to have a feedstock collection process that was sustainable and economically viable in this whole piece. And so what this tells us is that collaborations really are a necessary component to be able to work in these areas and be really successful in the future. And for our company, at least, it's caused us to think about this more deeply, and we're trying to develop a concept here called the Global Collaboratory, which I think is really aligned with the aspirations that GCEP has as being global in its context, but a collaboratory where you bring in different science partners to be able to take on the challenges of the future, to innovate, to collaborate, to invest, and to engage around important solutions here. So this is my first GCEP meeting. I'm really pleased to see the depth and breadth of the work that's going on here. I think what you're doing here really is consistent with what we see as a global collaboration working on the important challenges of our time. And so I thank you for giving me the opportunity to share our experience this afternoon.
To what extent are you involved on the feedstock end of getting to high yield energy crops? You talked about the harvesting, the next step down, but I was wondering about the breeding techniques and experiments with high yields on acre scale and things like that.
Yeah, good question. We're involved in this in two ways. Number one, with our Pioneer Seed subsidiary, we have a sales force that penetrates the cornfields of Iowa and Illinois on a daily basis, and are really in a position to work with the farmers to develop the assembly of the corn stover necessary to feed this commercial plant that we have in Iowa. So we work with farmers on getting that supply chain in place through the primary vehicle of that subsidiary. But then in Pioneer as well, in fact, we work on a breeding of feedstocks in corn for the conventional ethanol industry to have optimal yields flowing from that process. But we also work on breeding of energy crops that can grow on land which is not arable for food productions that would be a potential feed source. And so the reason why we put our first plant in Tennessee is because we saw switchgrass as a potential opportunity to provide a cellulosic feedstock there. And in fact, in our early experiments, we worked on switchgrass, and we're continuing to see that as an opportunity as we continue to develop it going forward. So we are very interested in the feedstock part of this. In fact, it's critical when you look at the economics of getting a feedstock delivered, in a state at the right economics to make the rest of the process viable. Yes?
Could you speak a little bit about how you engage with outside entities? Obviously here we're the university part of the world, but I'm sure you engage with startup companies and other providers. Could you talk a bit about how you engage with them? Do you invest, acquire, joint venture, partner, and so on?
Yeah, well, we do all of those things, and we do them in different circumstances. And so one of the primary ways we work with smaller companies is we do venture level investing at early stages to get a window into technologies that we think are going to be commercially important for our company going forward in the future. And a really good example of that is a small company called Innovalite that was making inks that allowed increases in efficiencies in solar cells just down the street here, a couple of miles down south of here. And so we made a venture level investment in that company about 3 or 4 years ago, and then worked with them for a couple of years to really get a sense of whether that technology was really going to be interesting and contributory to the other programs we had on solar cell efficiencies. And then we actually acquired them about a year ago now, and they're part of the DuPont company. So we don't do that all the time. Very often we'll make a venture investment, and we'll just maybe license technology from that company as opposed to buying them outright. But this one we saw as a really good opportunity to bring together. They had expertise that really supplemented what we had in our company. We also have joint ventures. The cellulosic ethanol venture was to commercialize it was a joint venture between DuPont and Danisco prior to us acquiring Danisco. So we ran that as a joint venture for the first 4 or 5 years of its operation. We're pursuing biobutanol, which we believe is an important next generation biofuel in a joint venture with BP called Butamax. So we do almost every configuration possible, including lots of collaborations with universities on foundational sciences that are leverageable into ultimately into a commercial situation.
All right, we've got one there, and I've got one for you too, but I'll wait until after.
Okay.
Much of what DuPont is engaged in is energy intensive. I'm curious as to what the company is doing internally to reduce its dependence on fossil fuels.
Yeah, that's a good question too. In fact, we used to talk about that more than what we talk about now because, I don't know, maybe it sounds a bit old-fashioned, but our first thrust into energy in the energy space was to look at what we did internally and to drive our energy consumption down. And so we set, for example, in 1995, we set some environmental goals that had greenhouse gas reduction targets associated with them and energy efficiency targets associated with them. And we set them in 1995 for 2005 and had accomplished all of those things by 2004 and set a new set that again have those components and actually even a more sophisticated set of goals where not only do we have goals for ourselves to be more energy efficient and less greenhouse gas intensive, but we have goals for our customers. So goals for our technology organization to develop products that enable our customers to be more energy efficient and less greenhouse gas intensive, and those are our 2015 goals that we're working toward. So we do it. There's a truism. People say that what gets measured gets done, and how we've addressed that is we've set really aggressive targets in both areas, and we have, as a company, we have a very large manufacturing footprint. So driving our emissions down to zero and driving our energy consumption down as far as possible is an important economic contributor to the company's performance.
Okay, so now I'll ask a question, and actually you've partially answered it, but I thought it would be fun to talk about it. So when we were looking for some new partners at GCEP, there are lots of criteria we look for. We look for companies with deep research capability.
Deep pockets, I thought you were going to say.
Well, deep pockets too, but really, a company could have all the money in the world, but it's really, this is a partnership. This is not a funding mechanism, but at the same time, we're looking for companies who have a value system that's sort of aligned with the GCEP mission, which is to provide affordable, accessible energy with very low greenhouse gas emissions. But I looked at your sustainability report, and I went on the web and I read it, and actually I was really fascinated that you have, I think there were 3 major categories, and one of it was sort of your own sustainability footprint, how you were dealing with water and how you were dealing with energy. So that was one category, and I think in every sustainability plan, people expect to see that. But then there was a second category, which was sort of things that are in the pipeline, new products and services that would help your customers be more sustainable. And then there was another metric, which was, well, how many of these products are we, what's our revenue stream in these new areas of business where, we hope to build a business. And I just wonder, so if you could say a little bit more about your sustainability plan and how that's, woven into your business strategy.
Yeah. Okay. Well, it's woven in, very publicly through the vehicle of our stated goals that we audit ourselves and have third parties audit on an annual basis, and as you just indicated, they have evolved. If you looked at the first 2005 goals, they were directed toward almost exclusively internal energy efficiency and greenhouse gas footprint reduction, and emissions of chemicals, carcinogens, and ensuring that our environmental performance got better and better over time. The second generation then said, gee, we have an opportunity to work with our customers to have innovations flow downstream that allow them to have better environmental performance, and it attracted a whole array of customers. I mean, this was not only kind of good environmental and sustainability stewardship, but it was good marketing, because in fact it attracted people to want to partner with us because they saw in their industries challenges that they had around sustainability, and they saw DuPont as a potential partner to be able to, for them to accomplish their goals. And so that second part of it, we audit against the metric of how much we're spending of our total R&D spend on this particular area, and we have goals associated with that. And then this is a laborious process for a company that makes 35,000 different products, is we quantify the revenue associated with products that are in fact playing that role within the sustainability context. So it is something that is, we thought, took the thinking to the next level, and it was important not for us simply from a public relations point of view or satisfying our own ambitions, but it was an important thing to solidify and strengthen the partnerships that we had with a broader set of stakeholders, including customers that buy more from us as a result of this.
Great, okay. Thank you. Okay, any more? I think we've got another. Okay, all right. Well, thank you for a wonderful talk. Thank you so much.